Section 5.2, Addition and Subtraction of Polynomials. Before we actually get to the addition and subtraction, let's talk about what we mean by polynomials. And before we get to that, we have to discuss these things called monomials, because polynomials are made up of monomials. A monomial is a number, variable, or a product of numbers and variables raised to natural number powers. So remember that natural numbers were the set containing 1, 2, 3, etc. Those were the natural numbers. So I've got some terms here. Which of them are also monomials? So is it a number, a variable, or a product of numbers and variables raised to natural number powers? Basically, if we see any non-natural numbers, exponents on variables, it is not a monomial. This is not a monomial because it had a y to the negative fifth power. Okay, so 7, that'll work. It's just a number. Z to the ninth, that'll work. It's a variable to a natural number power. 9 is natural. 19x squared, that's fine. It is a product of 19 and a variable to a natural number power. X to the 2/5 y, would that be a monomial? It would not, because of the 2/5 power. 2/5 is not a natural number. Negative 42 mp to the ninth. This will work. It is a product of a number, negative 42, and variables to natural number powers. M is being raised to the first power here. 1 is a natural number, and p is being raised to the ninth. Again, a natural number. Now, if we have a monomial, the degree of the monomial is the sum of the exponents on the variables. And we call the numerical factor of the monomial its coefficient. So if we consider the monomial 7 from the previous slide, the degree is 0. Because there are no variables. The coefficient is 7. It's the numerical factor. Z to the ninth. The degree is 9. There's only one variable, so there's only one exponent, and it is 9. The coefficient is 1. We understand we have a 1 times z to the ninth there, so the coefficient is 1. 19x to the second. The degree is 2. There's only one variable present. It's being raised to the second power, so the degree is 2. Coefficient is easier in this case, 19. Negative 42 mp to the ninth. The degree is 10. Remember, we have an m to the first and a p to the ninth. 1 plus 9 is 10. So if there's more than one variable in the monomial, we add the exponents to get the degree. The coefficient is easier, negative 42. Now, if we have a polynomial is a monomial, a single one, or a sum of monomials, a whole bunch of them. The degree of a polynomial is the degree of the monomial with highest degree. So we look over the polynomial and we say which of those monomials has the highest degree. That's the degree of the polynomial. Another term involved with polynomials is what's called the lead coefficient. The lead coefficient is the coefficient of the monomial with highest degree. So let's see some examples. All of these expressions on the left are polynomials. Let's determine their degree, their lead coefficient, and if they have any other special names. Alright, so negative 98. Does it have what is its degree? No variable present, so the degree is 0. Lead coefficient, well, there's only one coefficient, so it must be negative 98. And as we saw, this is called a monomial. Sorry, 2x minus 7. Alright, so let's consider the degree. Well, the degree of the first monomial is 1, right, because there's an x to the first. And the degree of the second monomial is 0, because there's no variable present. So the degree of the polynomial is 1. The lead coefficient is the coefficient of the monomial with highest degree. So we're looking at this monomial. The lead coefficient is 2. This is called a binomial because it has 2 monomials. Bi meaning the prefix for 2. Negative 5z plus 9z squared plus 7. The degree. Well, let's look at the degrees of the individuals. This is a degree 1, degree 2, degree 0. The highest of those three, degree 2. The lead coefficient. The coefficient on that monomial is 9. Since this has 3 monomials, it is often called a trinomial. Alright, why don't you try the next two on your own? Determine the degree and lead coefficient. Don't worry about any special names. Alright, so let's see. The first monomial has degree 3, degree 2, degree 1, degree 0. So this has degree 3, and the lead coefficient is negative 2. Notice also that this polynomial is written in what's called descending order. The polynomial of highest degree is written first, and then the degrees descend to the right. Notice that the next one is not written in descending order. It is written in ascending order. Alright, looking at the degrees again. Degree 0, degree 1, degree 2, degree 5. The highest degree is 5, so that's the degree of the polynomial. And the lead coefficient is the coefficient on that monomial, and so it would be the lead coefficient is 1. We generally like for polynomials to be written in descending order. Alright, adding polynomials is relatively simple. To add polynomials, all you have to do is combine like terms. So for example, if I had 9x squared minus 5x plus 7 plus 12x squared plus 4x minus 10, all I do is combine like terms. Alright, so I've got x squared terms, combining them, 21x squared. I have x terms, combining them, I'd have a minus x. And I have some constant terms, and so I would have a minus 3. Why don't you try the other one on this slide on your own? All right, using a similar process, I've got some x squared terms. So I'd have 4x squared. I have some x terms. That would be a plus 8x. And I have some constant terms, minus 5. 4x squared plus 8x minus 5. All right, why don't you try these on your own as well? All right, so 4z to the fourth plus z squared minus 10 plus negative z to the fourth plus 4z minus 5. All right, I've got a z to the fourth term that matches with this minus z to the fourth, so that would give me a 3z to the fourth. Now I've got this z squared term, but it doesn't combine with anything, so I'll just write plus z squared. I've got this plus 4z that doesn't combine with anything, so I'll just write it. And then finally I have a couple of constant terms that combine to minus 15. Notice I've written this in descending order. A squared plus ab plus b squared plus a squared minus ab plus b squared. Again, I've got some a squared terms. So that would be 2a squared. I've got a plus ab and a minus ab. Those are opposites and would add to 0. So I'm not going to write anything in their place. And then finally, I've got a b squared and another b squared. So that would be a plus 2b squared. Before we can subtract polynomials, it's a good idea to understand what the opposite of a polynomial is. To find the opposite of a polynomial, simply change all of the signs of the polynomial. So for example, if the polynomial is 17x plus 12, the opposite of the polynomial is negative 17x minus 12. I've simply changed all of the signs. Find the opposite of the remaining two polynomials on this slide. The polynomial is negative b cubed plus 3b. Its opposite would be positive b cubed minus 3b. If the polynomial is 7t squared plus t minus 10, the opposite would be negative 7t squared minus t plus 10. To subtract polynomials, add the opposite of the second polynomial. It's the same as subtracting with regular numbers. Subtraction's addition of the opposite. So if we had 9x squared minus 5x plus 7, subtract 12x squared plus 4x minus 10, I would rewrite this as 9x squared minus 5x plus 7, add the opposite. And to find the opposite, I just change all of the signs. So I'd have a negative 12x squared minus 4x plus 10. Now, since it's addition, I simply combine like terms. 9 plus negative 12, negative 3x squared. Negative 5x minus 4x minus 9x plus 7 plus 10 plus 17. All right, why don't you try the next one on your own? Subtraction is addition of the opposite. So I'll leave the first polynomial alone, and I will add negative 2x squared minus x plus 2. Combining like terms, negative 3x squared plus 5x plus 10. All right, why don't you try these two examples on your own as well? All right, so 3z to the fourth minus z, subtract negative z to the fourth plus 4z squared minus 5. I will rewrite that as 3z to the fourth minus z plus positive z to the fourth minus 4z squared plus 5. Now it's addition, combining like terms. I have 3z to the fourth and a z to the fourth, so that would be 4z to the fourth. I only have the 1z squared term, so minus 4z squared. I only have the 1z term, so minus z. And I only have the 1 constant, so plus 5. A squared plus b squared, subtract negative a squared plus b squared would be a squared plus b squared, add a squared minus b squared. Combining like terms, I would have 2a squared, and I have a plus b squared and a minus b squared. Those are opposites and would add to 0, so I simply have 2a squared.